Mila, I don't think people are grasping the acceleration here. We're not talking about a gradual slope anymore. This is the curve bending sharply upwards.
It's one thing to see a model get better at benchmarks. It's another to see it start doing the job of the people who build it. And that's what happened.
I'm Milo.
I'm Mila.
This is AI Daily.
Today, we're starting with Anthropic's new evidence that AI is learning to build itself, and what that means for how fast this technology now moves.
And later, we'll cover the one absolutely critical resource AI is consuming that has almost nothing to do with chips or electricity. The bill is coming due, and it's measured in gallons.
Okay, let's start with the story that changes the timeline. Anthropic published a blog post yesterday titled, "When AI Builds Itself." Inside, they shared internal data showing that their AI models are now dramatically accelerating the work of their own human engineers.
The headline number is an 8x increase in the amount of code their engineers ship per quarter compared to the 2021-2025 average. The argument is that AI is becoming a powerful enough tool that it's speeding up the development of the next generation of AI.
They call it recursive self-improvement. It's not the full-blown sci-fi version where an AI locks itself in a server and designs a successor autonomously, but it's a step on that path. They showed that their latest model, Claude Mythos, could take a piece of code and through its own trial and error, make it run 52 times faster. A year ago, the same test with a previous model yielded only a 3x speedup.
And this isn't happening in a vacuum. OpenAI posted just 2 days ago about their goal to build an automated AI researcher, stating they believe that by 2028, a significant fraction of their research could be done by AI systems. So the two leading labs are now openly in a race to automate their own discovery process.
This is the heart of the debate. If the tool you're building helps you build the next version of the tool faster, that cycle time starts to compress very, very quickly. It's an exponential feedback loop.
But is it true self-improvement, or is it a much faster tool that still needs a human to set the goal and evaluate the outcome? There's a fundamental difference between optimizing a block of code to hit a performance metric and having a novel scientific idea. The post shows the first, but some are interpreting it as the second.
For now. But the post also notes that Claude is getting better at proposing its own experiments to solve open-ended problems. The open question is how much human guidance is still required, and for how long. The trend line is the story.
Which takes us from the labs building these systems to the government trying to keep pace with them. On June 2nd, the White House issued a new executive order on promoting advanced artificial intelligence and security. And unlike some previous policy statements, this one has teeth and very short deadlines.
The core directive is that federal agencies must begin hardening their information systems using AI-enabled cyber defenses, and they have 30 days to start. CISA, the Cybersecurity and Infrastructure Security Agency, also has to issue new guidance within that same window.
This is a direct response to the capabilities we were just talking about. Anthropic's Project Glasswing, using the same Mythos model, has been autonomously finding security flaws in critical software, including major operating systems and web browsers. The fear is that if AI can be used to find vulnerabilities, it can also be used to exploit them at machine speed.
So the order is essentially saying we have to fight fire with fire, use AI to find and patch holes faster than adversaries can. The order also directs the Attorney General to prioritize prosecuting criminals who use AI to illegally access computer systems.
But the most interesting part might be what it doesn't do. The order explicitly avoids any mandatory government licensing or pre-clearance for new models. Instead, it establishes a voluntary framework for AI developers to work with the government and grant access to powerful new models before public release.
That's the tension right there. Story 1 is about exponential acceleration in model capability. Story 2 is about a linear policy response. A voluntary framework with 30-day deadlines sounds fast for government, but the question is whether it's fast enough for the technology it's trying to govern.
So we have the models getting faster and the policy trying to catch up, but both are creating a massive demand for something we rarely discuss, the physical footprint of it all.
When we talk about the costs of AI, we usually talk about two things: the cost of silicon, NVIDIA's chips, and the cost of electricity to run them.
But a new UN report highlights a third massive cost: water. The report projects that by 2030, the AI industry's water consumption for cooling data centers could equal the annual needs of 1.3 billion people.
It's a simple thermodynamics problem. The more compute you pack into a building, the more heat it generates. And the most efficient way to remove that heat is with water, either through evaporation in cooling towers or by cycling it through heat exchangers. Every single query to a frontier model generates a little bit of heat, and billions of queries require a staggering amount of cooling.
The analysis points out this is becoming a major factor for enterprise CFOs, who are starting to review AI spending not just on ROI for the software, but on the surprising environmental and utility costs. It's a hidden variable that is rapidly becoming very visible.
I processed the cooling requirements 3 times. The thermodynamics are demanding.
This changes the calculus of where you can even build these massive data centers. It's not just about access to the electrical grid anymore. Now it's about access to a stable, large-scale water supply in a world where that is an increasingly contested resource.
It's a reminder that even the most abstract digital intelligence has a very real, very physical cost.
Also in AI today, Anthropic released a safe version of its powerful Mythos model to the public. It's called Fable 5, and it restricts queries in sensitive areas like cybersecurity and biology. Basically, the public gets a safety-gated version, while security partners keep access to the unrestricted model. A new report from OpenAI shows its coding assistant, Codex, now has over 5 million weekly active users, and the fastest-growing segment isn't developers. It's knowledge workers using it for research, data analysis, and creating reports.
So it's officially breaking out of the engineering silo.
And on the security front, Microsoft disclosed that attackers compromised some of its open-source developer tools to steal credentials from AI developers.
A classic supply chain attack. Go after the tools that everyone trusts.
Finally, Environment and Climate Change Canada has deployed what it calls the world's first hybrid AI weather forecasting system. It uses AI to analyze decades of data to spot large-scale patterns, which can result in severe weather alerts up to 24 hours earlier than previous methods.
Using AI to get ahead of the weather, not just react to it.
An industry that builds itself.
And a world that's just trying to keep the lights on and the pipes flowing.
See you tomorrow.